Okay, on your cards, yesterday, you guys worked on connecting those together. Okay, so let's check those. And so here are the answers. Number 1 and number 8 are both ones that were skewed left. Okay, so the number 1 card was skewed left, but it had a very large standard deviation. And number 8 card was skewed left with a much smaller standard deviation. Okay? So let me talk to you about this. This is also very interesting looking here. Here we have a very small quartile. The reason that we have a very small quartile on this picture here, letter D, box plot D, is because you have a lot of data in one bar. A lot of data in one bar is translating to a very small quartile. Alright, as opposed to number 1, which is also skewed left, there is much more data further away from the center, so therefore it's a much larger standard deviation. Okay? Alright, numbers 2 and 3 are symmetric. So let's look at those. Number 2, you have quite a bit different, smaller standard deviation than number 3. And look, I want you to take a look at these pictures. This one is unimodal and stuff is closer, data is closer to the mean. That is why you have a much smaller standard deviation. Whereas this data is so far away, it's almost even bimodal because you dip down in the center. Alright, now I want to actually make an important point. So this is a new point that I want to talk to you about. If you only are looking at the box plot, if you are only looking at the box plot, can you tell if the data is symmetric or skewed? Yes, you can. Okay. If you are looking at the box plot, can you tell how many modes, whether it's unimodal, bimodal, multimodal, can you tell how many modes the data has from the box plot? You cannot. So you need to keep in mind that you cannot tell the modes. You cannot tell that it's multimodal or unimodal or bimodal from the box plot. You have to have a histogram or a stem plot or a dot plot to be able to tell the modes. All right. Number 4 and 5 are both skewed right. And then we have actually pretty close standard deviations. So that was something that makes it a little difficult because your standard deviations are relatively close. But from that, you can also tell on the range that this one ended at 20 and this one ended at 10. Look at how small this quartile is. What makes this quartile so small right here? Correct. You have a lot of data in this area right here. Okay? So most of your data is right there, and it's also probably just like the same number. 40, 40, 40, 40, 40, 40, 40, 40, 40. So a lot of 40s. Or 39s, whatever that is. Okay. Next. Number 6 and 7, they are also symmetric. And wow, look at the differences in their standard deviation. The standard deviation number 7 is more than twice that of number 6. And you can tell that from how far this is spread out compared to this. And look, see all the data on the edges? That's what's making that such a large standard deviation. Because you have many pieces of data on the farthest edges away from the mean. Okay. And then we already went over number 8. All right, any questions on that? Box plot and histogram. You have to be able to do that. I will tell you that on Friday, you will be having a quiz over this week's kind of, deeper level thinking on these concepts. And um, then, next Tuesday, because we do not have school on Monday, so we will then go over a review on Tuesday, and you will test the more enriched, deeper thinking of these concepts a week from today, next Wednesday. Okay? So I do anticipate giving you homework tonight that has multiple choice questions that are deeper level thinking. All right, let's look at your homework from Monday night. The first page looks like this. You have your box plots. All right, so box plot A was taking $10 off of each value. So guess what it did? It shifted everything down 10. So the shape is still exactly the same. It's just shifted down 10. All right, now look at this second box plot. 10% off of each of the original values. You need to think of 10% off means that every piece of data is 90% of its original. So every piece of data is a part of the original. It's 90% of the original. So you know what's happening is that this picture is being compressed by 10%. So not only is the median a smaller value, the stretch on it, so the IQR and the overall range is also smaller 10%, 10 percentage points. Okay? So everything got affected that way. All right, and number 4, if you had the health clinic giving a straight up $1,000 raise, the average increases, the median increases, the IQR and the standard deviation do not change. However, if you give a percentage raise, that's a 1.04 multiplier, then the new upper and lower values are multiplied by 1.04, and the IQR and the standard deviation do change. Why? Because they are both stretched or multiplied or dilated, however you want to say that, by 4%. Okay, now the next page is the cumulative box plot problem. Not cumulative box plot, sorry. Cumulative frequency problem. So our first picture was out of 80. And then after you collected this data, so I'll let you check your percentages over here. After you collected this data here, then you graphed it on the other side. Okay, so you graphed those percentages. What did changing it into percent do to the picture? It stretched it out, because now it was out of 100% instead of just out of 80. So your picture then looks more like this. You can see it's similar in shape, it's just stretched out longer and skinnier and narrower. Okay, and then let's answer those questions. So the first question we actually did together the other day. What percent of cars travel less than 30 kilometers? And that's 35% of them travel up to 30 kilometers. How do you find the center of this distribution? You're going to look at the what? The median, which is located where? At the 50% mark. That's what I was going for. So I have that marked here in red. You can see that you would go across here to the mark and see what that is, and that's about at 33. And then the next question is, what's the 60th percentile? So I had drawn that in blue. And how can this be explained in words? 60% of the vehicles traveled 34.5 kilometers or less. If you have this word missing, then you are missing the whole entire concept of a cumulative graph. That's saying that everything up to this point. So if you don't understand that much or less, You are missing the whole reason of a cumulative graph. Okay. And then there's a 5-number summary. I don't know why I put 19. It might be 18 on that 5-number, that lowest minimum. Okay. And could we find the mean and standard deviation? No, because we do not have the individual pieces of data. And we knew that it did come out of 80 pieces of data because we found that in the first graph. Okay, so that's going over this one. Any other questions on those 3 things? All right, so then let's go ahead and, yes, ma'am. Okay.